hypothesis should be your hypothesis should be look like the more x, the more y. Okay? For example, the prettier a girl is, the more popular she is. Something like that. Okay? So your hypothesis look like this. So this is most straightforward way to state your hypothesis. The more x, the more y. It means that when x increases, y increases. So what you can do, you can collect the data on x and data on y and match them, right? The prettier a girl is, the more popular she is. I think it is not gender correct, so let me change it to man. The more handsome, more handsome boy is, right? The more popular he is. So in the case, in order to test this hypothesis, you can measure the extent of handsomeness of the man, 1, 2, 3, 4, 5, 6, and check number of girlfriends, for example, 1, 2, 3, 5, 6, and you can match it. Something like this, right? Yeah.
So the hypothesis is, isn't it like guessing?
Yeah, it should be relevant to your research question. Okay.
Yeah, but that is fact.
Okay. Originally, hypothesis should be driven from the literature review. You have to go through existing literature. You have to go to Google Scholar or something like that, existing literature, and then you have to find some idea about that. But given that we don't have enough time, I just want you to go directly into the hypothesis. Just generate your own hypothesis. Okay? And then the hypothesis, of course, hypothesis is original. If someone already checked your hypothesis with data, then there is no point of doing it again. Okay? So when you developed your hypothesis, you have to keep checking it whether someone did it already or not. Okay? So then this is due next week. Due, okay, 23rd. So due 22. Data sources. Yeah. So homework number 1. Homework number 1 is due 22nd is hypothesis and data sources. Okay. Now homework number 2 is due next week. No, this Friday. So it's due due AM. And then this Friday. So this Friday, okay? By this Friday. Now, how many, who came to TA hour for R? How many of you? 1, 2, 3, okay, 4. A lot, okay? Then it's fine. So homework is now your programming homework. By the way, I think you can, how you can submit it. Okay, you can also submit it to, and then, actually 뭐래. Okay, by replying. So again, you can take a look at other people's homework. So the thing is that to like sure, once you submit your homework here, then there is a concern. I may have a concern that you copy other people's homework, right? For example, Igyu upload his homework, then Kim Namju can download Igyu's homework and copy, right? Of course, it is impossible scenario, I know, impossible, but still, I mean, it is impossible maybe for you, but I cannot rule out that possibility. So, the earlier you upload your homework, the better your grade. So there is a horse race. You have to win quickly. Okay? So your homework is price, European call, and put option. That's the easy part. When, but I'm slow at modification. When dividend follows normal distribution at their maturity. Okay, so basically this homework requires you to write R code for Black-Scholes pricing model. But usual Black-Scholes pricing model, in their model, like dividend is fixed. But I want you to make dividend stochastic. I'll give a hint. So, hint one. Black-Scholes formula, okay? We have Excel file. You can download it. If you go to this web page, you can actually download it. Did you bring your laptop? No. Bill, did you bring your? Yeah. Please turn on your laptop and then you can go to this web page. And you can download this one into the Excel file, right? So there is Excel file and Excel VBA code, even R code. This is directly relevant to your homework. But anyway, yeah, please. So here, the Excel file is basically black model, black version of Black-Scholes model. Okay, so basically this is call option formula and put option formula here. So, this is much easier way. Okay, I'll explain to you. Okay. Actually, if you just type Black-Scholes model on the web, then the formula is not so intuitive. Sometimes that formula doesn't include the dividend flow. So this is better. I want you to use this formula. Please remember Black-Scholes model in this way, not usual way. This is more intuitive way of actually even easier to remember in this formula. Okay, so here. Okay, so this is C thing. Okay, this is call option formula. Okay, this is put option formula, and then we have F. F is basically S multiplied by E R minus RD, let's say RD and T. So this is called futures price or forward price. This is forward price. Let's say this is futures price. Futures price. So it means that forward price or futures price has 4 elements. First, spot price. That's current price. Price of underlying asset right now. and the exponential of risk-free rate minus dividend rate. Dividend from flow from this one multiplied by time to maturity. Okay, so this is correlation formula and P here. Let me look at one by one. So this is basically E minus RT is basically this discount factor. So call option price is a discount, present value. Call option is basically present value of something inside of this one bracket. Likewise, put option is present value of something in bracket. So inside of bracket, we have this one. F is for the price, and ND1 minus K ND2. K is called exercise price. So it is call option. So you have a right to buy underlying asset at price K. Okay. Put option is right to sell. So K you can sell underlying asset at price K. So K and minus D2 minus F and minus D1. Here D1, D2 looks like this. Log of Fk plus sigma square here. Sigma, so again, F is this for the price, K is exercise price. Sigma square is called volatility. Annualized volatility of underlying asset divided through multiple T time to maturity, and sigma volatility root T. And D2 is simply D1 minus sigma dt. Here N is called cumulative normal distribution function, right? So suppose this is the CDF, no, probability density. Suppose this is probability density function for standard normal distribution, and let's call this is X, and the size of this area is called Nx, right? So again, now we are done. In order to calculate call option price and put option price, we need 6 input. Okay, underlying asset price, risk-free rate, dividend rate, time to maturity, exercise price, and then volatility. If we have these 6 things, we can calculate call option and put option price. Okay, so let's go to our Excel file. Okay, there's Excel file. So we have 1, 2, 3, 4, 5, 6. 6 input, right? So sigma here volatility 22% per year. Current stock price is $100. So stock strike price is $105. Time to maturity is 2 years and 6 months. And risk-free rate is very low. It is 0.55%. You can change it. They are all connected. So once you download it, you can change it. If you change it 1%, then this number changes, right? This number changes. Okay. And then dividend rate. So in this case, dividend rate is higher than risk-free rate. So this stock is high, dividend rate is high, right? Dividend yield is high. So around 2%, they pay around 2% of their stock price as their dividend. Now, first we can calculate discount factor. In this model, I simply call this one as B. Let's say B is EA minus RT. So it is discount factor, right? Changing $1 value time t into the present value. So discount factor P. So P is simply ERT. So right, exponential of minus RT, right? So actually I defined here RF is basically this one because I defined the name range, and then here RF, right? RF C5 I defined range as RF, right? So exponential RFT, T is this one, and for the price is S, right? This one. So S multiplied EXP RF minus QT. Do you know how to use? Of course you can connect it, but once you define range in Excel, it is much easier to deal with. Have you ever used a defined range function in Excel? No. Anyway, it is a very useful one. Okay, very useful. So it's easy. For example, you can call this one. No. So it is basically what the name of this cell is C14, right? C14. But if you keep referencing this one, if you write down C14 always, it is not convenient. Therefore, sometimes you want to define name range, and you can call this one like temp. And then when you type temp here, then it gives you this number, right? Let me delete this one. Delete. Okay. Remove. Okay. In Excel, so it is very convenient function. Define range. Any question? 무슨 말인지 알겠지? 네. 엑셀에서 셀의 이름을 정할 수 있는 거예요. So, do you understand what I'm saying? Yeah. So this is very convenient function. So okay. So this is for the price. I defined the for the price. Now D1. Well, D1 is again simply this one. So ln fk plus sigma square t divided by sigma t. So D1. D2 is D1. So okay, let's call this one define name range is D1. Oh, this is already D1. C10. Yeah, C10 already D1. So this is D1. D1. Yes, D1. And this is D2. Yeah, D2 is D1 minus sigma. And call option price is therefore B, discount of F. So N, in Excel, this N function is norms distribution. Norms this. The name is a bit long. Norms this. So in Excel, this N thing is in Excel. Norms district. Norms dist. In Excel. Okay. Norms this is D1. K norms D2. Likewise, the put option price is discount of K norms this minus D2 F norm this minus D1. So we have a call and put option price. Now, in order to check whether our call and put option price is alright, I want to check put call parity. So if we believe put call parity, in put call parity, this should hold. In put call parity, C minus P should be equal to discount of F minus K. Here, F minus X, F minus K, right? So this is called put call parity. So C minus P discount of F minus K. So C minus P is, so call minus put, and P forward minus K. So they are same. So our model is right. Any question? So this is a put call parity, very important one. What? Dividend rate is here, right? F. It is included in F. Right? Dividend rate is in F. So it is everywhere. F. What? 무슨 말이야? 아니, 디비던드 레이 0이 아니라 여기서는 지금 1.87%잖아. 근데 디비던드가 있을 땐 풋콜 페러티 교과서에 이렇게 써야지. 네? So, I mean, it is important to remember 풋콜 페러티 in this way as well, because in the usual textbook, dividend is not taken into account. So when there is dividend, 풋콜 페러티 looks like this. Here F is this one. So remember 풋콜 페러티 in this way, not the other way. This is the best way. Okay? So this is called 풋콜 페러티. I'll explain to you later why this holds. You can just couple of graph. I mean, it is obvious. But this is 풋콜 페러티. So it means that this is our exactly the same our model is right. And then sometimes we call the ratio between strike price and then let's call this one is S over K. Yeah, S over K. As like we usually call money needs. whether it is in the money or out of money. It is less than 1, so it is out of the money option, right? Strike price is higher than current stock price. So for call option, it is out of the call option in terms of money needs. But for the put option, it is in the money. But in the industry, actually, when we define money needs, we define actually the ratio between this one, right? Okay, F, no. F, forward rate divided by strike price. This is more popular way of dividing money needs. Okay, ratio between forward price, not spot price. Because what eventually they have to pay is forward price in the future, not spot price. Okay, so forward price, the ratio between forward price and the strike price is more popular definition of money needs. So again, it is less than 1, so it is call is the money, call is out of the money, and put is in the money. Am I too fast? 무슨 말인지 알겠죠? Yeah. Bill, is it clear? Yeah. 여러분 다 다른 파생상품 수업 들었지? 그러니까 이거 다 배운 거 아니야? 그렇지? 네. 이상빈 교수님한테 세계적인 대가인 이상빈 교수님한테 들었잖아. 그렇지? 다 배웠잖아. 어? 그쪽 분야의 세계적인 대가분한테. 응? 이상빈 교수님 수업 안 들은 사람 여기서? 없네. 다 들었네. 다 알겠네. 그럼 설명할 필요도 없겠다. 됐어. 오케이. So, I mean, this is a fractional formula, right? 머니니스가 뭐라고? 아, 머니니스 검색해봐. 여기 내가 그 수식이 적어줬잖아. 머니니스가 뭔지. 스톡 커런트, 그러니까 머니니스 스팟으로 이렇게 머니니스를 보면 비율. 그러니까 현재 스톡 프라이스가 얼마인지. 그리고 현재 옵션의 계약에 들어있는 exercise price가 뭔지. 그래서 you can think of money needs. Money needs the extent of money, right? Extent of money. How money it is, something like that. So it is a ratio between current price and strike price. So from the perspective of call option, right? Call option is exercised only when stock price is higher than strike price, right? So it means that this is less than 1, so it is not in the money for call option. They have like $5 more to go to make profit, at least $5 more to go, okay? But we can say just $5 as money is not good definition because it is not scalable, right? It is not scale, it is not normalized, it is dollar amount, right? So $5 is money needs from the perspective of call option, but it is $5 is just dollar. We have to normalize it in terms of notional value of something. So we normalize it with strike price, okay? So it is basically the distance between current stock price and strike price. From the perspective of call option, how much they have to go, stock price should go up in order to reach in order to make money. So it means over 5% to go. Right? About they have to go up about 5 or more percent. They are currently owned at 95% now. So they have only 5% more to go to make profit. So it is out of the call. But from the perspective of put option, now they can sell it at $105. So from the perspective of put option, well, it is 5% like overvalued. So put option in the money. But in case of futures, I mean, because we have to take into account the time value of money, it is more like a tough measure. More, the buy is higher to become a money. But now we have to take into account the time value of money. Okay. So anyway, this one is correct because we have a put call parity also holds. And this is Excel VBA code. If you are interested in, you can plug this one, you can run the program. And then this is now R code. R code, okay. Okay, so that's R. And then you can copy and paste. Right, run. So I want to calculate Black-Scholes price, like, so here input is S is strike price, 100, exercise price, $105, risk-free rate, 0.55%, dividend yield, RD, 1.87, time to maturity 2.5 years, sigma 22%, right? This value is exactly in line with this one. And if I run this program, right, call option value is 10.04, put option value is $18, right? Exactly same to this one. And then if you take into look at this function, we define function name Black-Scholes function, and this function has this input 2, 3, 4, 5, 6. And then value has a C2, and then it returns two values, and then BF. Yeah, I define B and F. This way B is discount factor, F is for the price in R. Right? If I put this one, computer cannot read it, right? You run this one, right? Comment, and this one is for the price, and this is D1, D2, value 1. So value is the string array, which has two values. So the first value in the value 1, so it is C2, so value 1 is put option price, call option price, call price, and second one value 2 in the second element of this one, which is again array with two elements. This is called put price, and we return these values, then it returns. Okay, so if I fill this one, then this one. So it's okay. So if I copy, let me copy this entire one, and again, done, right? R is very easy. It is easier than Excel, isn't it? Right? Bill, any question?
What is values less than dash C2?
So it means that, so this is variable, and we define this one as a C2. C2 is just empty, like you can regard it's not exactly vector, but it is array of numbers, like a vector. And two empty space. Okay, it has a vector and it has two empty cells, and it has two elements, and then so value is like a vector of 2 by 1 vector, something like that. And for the first one we fill put option, call option value. For the second one, we fill this one is put option value. So here, this is very important one. Okay. So here, I define value, right? Something called the value is like C2, right? It means that in computer, in the PC, there is called something like the value. And then it has two cells, something is empty two cell. Okay, it has two elements, but they are empty now. And then using this one, we fill this one values actually as, right? So once we this one, then it is now currently empty, but only it has two seats. And we fill this one with this one first call option price, and second one with put option price. So after this one becomes a call, and this one becomes put. Okay. So this is the C2 is one way of generating array with two empty seats. And then later on, once we fill these two empty seats with value 1 and value 2, which is called put option price, and later we return the values. So the last one, we type values, then this Black-Scholes function returns this value thing. Now when we return, it has this, now it is not empty anymore. It returns two values, this one and this one. Value. Right. Here. Right. So in R, it returns two values, call and put option price. So, okay, it is easy to implement Black-Scholes price with R. This is easy part. But our homework is slightly more slightly more complicated because I want you to make now dividend, okay? This dividend part, dividend here in this formula, okay, where is formula? In this formula, dividend is fixed, right? But what if dividend follows normal distribution? Then dividend is not constant anymore, okay? So basically, we can calculate call option price. We can calculate the call option price when dividend is fixed, right? This is the call option price, and when we know the dividend, when we have a specific value of dividend, we can get call option price, right? Something like this. Right? Suppose we know every input. Suppose we know spot price, risk-free rate, volatility, and exercise price, everything. And then in addition, if we know specific value of dividend, then we can get the price of the call option, right? This, right? For given value. But because now RD follows normal distance, what you have to do is you have to do the integration. Right? Integration, and then RD, DRD. Okay, you have to do something like this. And it is not easy to do this one by hand, so you have to use a computer. Okay, here this phi is standard probability density function for standard normal distribution. So question, how to do it? You can do it by simulation. Okay, so for example, suppose you are interested in value of this one, sine, cosine, R. Okay, suppose let's say you are interested in the value of this one. Well, this is, of course, you can use Excel. You can use Excel practice. Yeah, practice. Suppose you can use this one then, sine, cosine, like 10. Okay, then you know value is minus 0.74, something like this. But what if R follows distribution with 2 and then 10 square, right? And then suppose you are interested in calculating this one, right? If R is constant, you can use it Excel. But if R follows this normal distribution, then if you want to calculate this one, then it is more difficult, right? While in order to do this one, you have to again do the integration, okay? Integration of this one from minus to infinity with standard probability density with this one and integrate R, right? This is definition of expectation. But again, that is hard, okay? So what you can do is you can use a simulation to calculate this one, okay? The idea is this one. Idea looks like this. From this normal distribution, you generate the random number. From this, you draw random number R, and then plug this one, and then you calculate. Another one, calculate this one. Iterate this one like 10,000 times, and then get the average. Then you can get to this one, because of law of large numbers. Okay? So for example, yeah, in this case, now I can simulate R random number, normal is okay. In this case, in Excel, inverse in Excel. Okay, so I'm just generating random number from, okay, so this is random number from 0, 1. So in order to make 2 to 10, I have to multiply 10 and then plus 2. Okay, so I'm generating random number. So I'm generating random number from this distribution. Okay, they are random number from this distribution. And for each one, I calculate the sine, cosine of this one. Okay. And then my answer is average of this one. Okay. So this is calculating this one by integration very hard. But using Excel like this is much easier. But I just simulated like 7 values. This is not enough. We have to like 10,000 times, but you can do it like a computer. Okay? So in Excel, in R, this is even easier. Let me illustrate this one with R. So for example, of course, first I have to define function. Like let's define function called sine, cosine. Okay. If I write here, you can write in real time. So let me define sine, cosine as a function R, only one element, such that sin cosine equals like the value here, value equals sine cosine of R, and then return value. So I just made a function. Okay, and then what I can do is I have to simulate. Okay, to simulate the number in R, there is called R norm. Then it generates 10 random number from standard normal distribution, but it is there from standard normal distribution. So if I add 2 and multiply 10, it generates 10 random number from normal distribution with mean 2 and variance 10 square. Okay, and then what I can do is now it is easy. Okay, so let's run this program. Okay, and sin, sine, cosine like 10, its value is correct. And then I can do the simulation such that sin, cosine, and then R norm. Let's make 100 numbers now. 100 multiplied by 10 plus 2. Right? So it's a 100 number. And what I can do is now mean, average. Done. This is my answer. So easy. Right? So even in Black-Scholes model, it is same. You can do it when there is uncertainty in dividend. Uncertainty in dividend here. Uncertainty in dividend. Where is it? Yeah. When there is uncertainty in dividend, then like a call option price is a function of the dividend, right? And where is uncertainty dividend, you generate many random number and calculate this one. Okay, generate many random numbers and plug the random number here, and then yes, average it. Then you can get the answer. I think I gave you too much hint. Okay, any question? Any question about homework? It is due Friday. Yes. No, dividend can be negative. It is possible. Dividend can be negative. It is possible. But of course, it is rare that dividend is negative. Believe me, dividend can be negative. Okay? It is rare. So if you don't want to make your dividend negative, then when you generate random, you can simply put absolute value or something like that. It is fine. Right? But here, I mean, it is up to you. It is very easy, or you can take an exponential of you can generate random number. So if you want to make it everything positive, okay, then you can like exponential If you take exponential of normal distribution, it is called log normal distribution. In log normal distribution, we will use a lot of log normal distribution for practical formulas or this class. But now, I just calculated this one such that this means that, okay, this means that okay, now this means that we are calculating, this means that we are calculating expected value of the sine and the cosine R, where R follows now log normal, not normal distribution. It's called log normal distribution. From, right, 2 tan square, which is equivalent to exponential of sine of cosine of and then exponential of some z, where z is from now normal distribution with mean to variance tan square. Okay, any other question? So, are you sure about homework? Yeah. Believe me, it is not difficult. It is called Monte Carlo simulation. Okay? This is very popular and powerful technique in finance. Homework, you have to discuss this one. Just one. Okay, so discuss. Write small essay whether option price increases or decreases as the uncertainty in dividend increases. We know that option price increases when the volatility increases, right? Volatility means uncertainty in underlying asset. But my question is whether price increases when there is uncertainty in dividend, not underlying asset price. Yes? 아니지. 그 노멀 디스트리뷰션은 그 평균이 2고 분산이 100인 노멀 디스트리뷰션인 거지. Any other question? Okay, let's go to today's topic. Today we will learn Brownian motion. Did you learn Brownian motion? What is Brownian motion? EQ, what is Brownian motion? You never heard of it? 이상민 교수님 수업 들었잖아. 배웠을 거 아니야, 그러면. 위너 프로세스 브라우니안 모션 그런 거 안 배웠어 아직? 아, 그거 안 나오나? 안 나오나? 김남규, what is Brownian motion? You know? You don't know? Bill, have you ever heard of Brownian motion? Okay, Brownian motion is important even in CPA exam. You know, even in CPA exam, there is a question about Brownian motion. Couple of days ago, I made some national exam problems. That is also very prestigious exam that every student want to pass. And even in the case, we made problems about Brownian motion. And there will be another Brownian motion problems in CFA as well. So you have to know Brownian motion in order to succeed in finance sector, especially if you are interested in getting CPA, CFA, or whatever exam. Okay? So Brownian motion is important. Of course, if you have a question, you can simply type Brownian motion in Google. Yeah, there is a good explanation about Brownian motion here, right? Wow, this is two-dimensional Brownian motion. The movement of this yellow one, this is a simulation of Brownian motion of big particle, dust particle, which is yellow one, that collides with a large size of smaller particle, this dark one, and which moves with different velocities in different random directions. This movement of this yellow particle is basically two-dimensional Brownian motion. You project movement of this yellow one, each axis, it becomes one-dimensional Brownian motion. Yeah, so it tracks the movement of yellow one. So this is a path of Brownian motion in 2D space, two-dimensional. And this is the, three different, this one is more interesting. This one is a Brownian motion in three-dimensional space, in the space, right? It's like movement of the gas. So if you project the movement of this gas, this one, into plane, then it is a two-dimensional Brownian motion. If you project this movement into one axis, it is one-dimensional Brownian motion, magically. In finance, of course, we deal with multi-dimensional Brownian motion, of course. But in this class, we'll use just one-dimensional Brownian motion. Not two-dimensional or three-dimensional, just one-dimensional. So one-dimensional Brownian motion is just up or down. Like a stock price. Stock price can go up or down. It doesn't go left or right. Right? Stock price cannot go left or right. So movement of stock price is not two-dimensional. It's just one-dimensional movement. It can go up and down. So we focus on one-dimensional Brownian motion. Yeah. And then definition of a Brownian motion is, okay. And sometimes it is called the Einstein process or Wiener process. Wiener process. Okay, Wiener process. This is one-dimensional Brownian motion. So it is movement just go up and down. So we track the movement of up and down over time. So it looks like a stock price, right? So it's one-dimensional Brownian motion. The Wiener process is a two-dimensional, Robert Wiener. Yeah. So one interesting thing about this Brownian motion is that this is interesting. Brownian motion of a trajectory particle in water. So it is three-dimensional movement of the Brownian motion. What is this one? Animated again Brownian motion like random occurrence. Torus. Ah, it is on torus. Good. Brownian motion in two sphere. Okay, one interesting thing about Brownian motion is that first, the Brownian motion is continuous. Continuous means you can use a pencil and draw Brownian motion, and then there is no jump. You can draw a line without putting your pencil away from the paper, without detaching pencil from the paper. So it is continuous. But there is one challenge in actually drawing this Brownian motion, because the length of Brownian motion is infinity, which means that you have to move your hand infinitely fast. So this is one Brownian motion from time 0 to 25. So suppose you are interested in the shape of Brownian in this area and you enlarge it. But thing is that, well, this one looks like same. If you enlarge this part 0 plus 0.1 again, then you will find this one again looks similar. Okay, so even if suppose you are interested in special segment of Brownian motion and enlarge it, magnify it, same pattern repeat. You will find repeated same pattern again and again. Okay? Like this one. You enlarge it, so because the same pattern emerges in infinitely, so it means the length of any small segment of Brownian motion, its length is infinity, because same pattern repeats itself. It is like a shape of the borderline. If you go to Korean Peninsula, hello Earth, explore, home, where it is? I want to go check Korea. Okay. It is Seoul, okay, and then it is Korea, okay. Suppose you are interested in the shape of this area, right? And then of course you can enlarge this part. Suppose you are interested, so this part looks complicated, right? And if you enlarge this part, well, this is more complicated, and you enlarge it, you can find another complicated one. And if you enlarge it, then you can find another complicated one. Another complicated one. You keep increasing the scale. You are interested in special segments, but their complicated pattern keep emerging, right? So again and again. 더 이상 복잡해지지 않네. But if you take a very look at it, then there is the between border and land, sea and land, it is also complicated, right? Because there is always wave, and then the line is always complicated. So it is similar to that. So in nature, we can always find these complicated, seemingly complicated, but same pattern emerges over and over. This one we can find very easily. It is called fractal. Seemingly complicated, but same pattern, like the shape of snow. If you look at the snow with a magnifier, then there is a complicated pattern, but interestingly, it is complicated, but same pattern over again. Right? Brownian motion is exactly same. Right? Same pattern over and over. But the thing is that still it is continuous, but when you actually draw this Brownian motion, you have to move your hand infinitely fast. Okay? And there is a mathematical definition about the Wiener process. A process is called Wiener process of Brownian motion if it satisfies these three properties. Starting point 0, not important. The function is almost surely everywhere continuous, basically continuous. So the difference between the two locations, location of the stock price different between stock price at time t and stock price at time s, it is normally distributed with mean 0, with variance is simply past of time, duration of time. Okay, I think this is all for today, and let's continue this one on Friday. Thank you, and see you Friday. Don't forget your homework due Friday.